So right from question number 4 in exercise 8.4, we are going to directly or indirectly apply the three identities, which are sin square A plus cos square A equal to 1, 1 plus tan square A equal to 6 square A, and 1 plus cot square A equal to cosec square A. And at situations, we need to interchange them in a particular form so that we can substitute them. So when it comes to the first subdivision in fourth question, which is choose the correct answer. So this is the question, which is 9 sec square A minus 9 tan square A. So now here, let me take 1 plus tan square A, or 1 plus tan square A in the place of sec square A. And what you're left with is this. Let me repeat it again. I have written the question again, 9 sec square A minus 9 tan square A. And we all know that sec square A is nothing but 1 plus tan square A according to the second identity. So I'm substituting 1 plus tan square A in the place of sec square A. Or you can also substitute whatever it is in the place of tan square A also. That will be sec square A minus 1. So here I'm substituting 1 plus tan square A in the place of sec square A. Now this 9 into 1 becomes 9. And this 9 into tan square A becomes 9 tan square A. And then you have minus 9 tan square A. So this is from the second identity. How sec square A became 1 plus tan square A, that is from the second identity. Now 9 has been taken inside the bracket. Now you get 9 plus 9 tan square A, and then you have another minus 9 tan square A in the expression. And then you cancel minus 9 tan square A plus 9 tan square A. And you're left with the answer, which is 9. So therefore the answer is option B. So this is how you do this question. With respect to the second sum, so the sum is quite, looks a bit complex. So what we are going to do is, we are going to convert every trigonometric ratio in the problem in terms of sine and cos. So what I mean by that, second subdivision, it is 1 plus tan theta plus, I'll do it in the right hand side. So the second subdivision goes like this. So it is nothing but 1 plus tan theta plus sec theta. And then 1 plus cot theta minus cosec theta. We should be very careful when we use the signs. So while copying the signs from the question as well. So the next step, this becomes, I told you that we are going to convert each and every term in terms of sine and cos. So tan theta is nothing but sine theta by cos theta. And sec theta is nothing but 1 by cos theta. So this is the first term. Likewise, 1 plus cot theta is nothing but cos theta by sine theta. And minus cosec is nothing but 1 by sine theta. Now we have converted each and every term in terms of sine theta and cos theta. Now the next step is to take the LCM. So this will become cos theta plus sine theta plus 1 whole divided by cos theta. When we take the LCM, and this would become sine theta plus cos theta minus 1 divided by sine theta. Let's see how to do question number 4, second subdivision. So this is the question, 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. So whenever we are given a question of this type, wherein it's a long thing and we don't know how to proceed, the main hint is to start off with converting all the trigonometric ratios in terms of sine and cos. So how do we do that? I'm taking this question, and here tan theta can be written as sine theta divided by cos theta, and then sec can be written as 1 by cos. Likewise, here cot theta can be written as cos theta by sin theta, and cosec can be written as 1 by sin. So all this we know how to convert tan into in terms of sin and cos. So sin and cos are called the two basic trigonometric functions. So if they have given a question which is kind of complex, you convert the individual terms in terms of sin and cos. However, this may not be always applicable. We will look at problems wherein we need not convert them into sin and cos also. So when we take the LCM, we are getting cos theta plus sin theta plus 1 whole divided by cos theta. So this is what we get, whole divided by cos theta after taking LCM. So let me explain the LCM step again. If you look at the red color on the screen, so this is like divided by 1. And both these have cos theta. So the LCM is cos theta. So you multiply this by cos theta in the numerator also. So that's how we are getting this. So cos theta, so the numerator becomes cos theta plus sin theta plus 1. And there's a common denominator which is whole divided by cos theta. And this is how we do. Likewise, if we take the LCM for the other term also, we get sin theta plus cos theta minus 1 divided by sin theta. Here also we are taking the LCM for all the three terms, whereas only the first term needs to be multiplied by sin theta in order to take the LCM. Now, again, it's becoming complex, but I'm trying to find a pattern. So I'm just rearranging the terms. So this I'm writing it as sin theta plus cos theta plus 1 divided by cos theta. And here we have sin theta plus cos theta minus 1 divided by sin theta. So this is something that we need to know. So what I have done over here is I have just interchanged these two terms. Since they are in addition, they can be put anyways. Like for example, 2 plus 1 can also be written as 1 plus 2. So likewise, cos theta plus sin theta, I have written it as sin theta plus cos theta. I have not changed the other terms at all. So, but why am I rearranging the expressions like this? In order to get a pattern, if you clearly observe carefully, you can see that this can be taken as one single term and this one can be taken as a separate term. Likewise, here also sin theta plus cos theta can be taken as one single term and one can be taken as separate term. And now you can see it resembles A plus B into A minus B, where A and B are the same. A is sin theta plus cos theta and B is 1. Only the plus and minus in between them is changing. So usually we have been used to applying A plus B into A minus B only for 2 terms. But here we are applying it for 3 terms, provided the first 2 terms have been taken as a single entity A. And the second term has been taken as a separate entity B. So now when we do this, this resembles A plus B into A minus B. So we get A plus, I'm just writing the formula. So A plus B into A minus B, which is nothing but A square minus B square. So now here it's we have to observe that carefully that A is nothing but sin theta plus cos theta. And B is just 1. Sin theta and cos theta put together is A. Now this will be A square minus B square. When you apply this identity in the numerator, you get A square. A is nothing but sin theta plus cos theta. A square minus B square. B is 1. And in the denominator, you will have sin theta cos theta. It is just a multiplication of the 2 terms. I write sin theta first, but that's not a problem. We can even write cos theta first. So these are the initial steps. Now what you do is, we will try to expand the sin theta plus cos theta the whole square. So which will become A plus B whole square, which is A square plus B square plus 2A into B. So this is the expansion of this term, this green color term. A plus B whole square will become a square plus b square plus 2ab. That's 2ab term is what I've written over here. And apart from this, we also have a minus 1 square. So that should also be taken into consideration. So I'm just writing minus 1 square is minus 1. 1 square is 1. So I'm writing minus 1. Whole divided by, you're getting sine theta cos theta. I'm not changing the denominator. Now we all know that sine square theta plus cos square theta is nothing but 1 according to identity number 1. So other things you have is 2 sine theta cos theta minus 1 divided by sine theta into cos theta. This is what we are left with. How did this become 1 according to identity? Or you can even mention that in the bracket by writing by or from sine square theta plus cos square theta equal to 1. So from this identity, this will become 1. And all the remaining terms are just there. Next step, 1 and minus 1 will get cancelled. And you are left with 2 sine theta cos theta divided by 2 sine theta cos theta. Now cos theta gets cancelled. Sorry, the denominator you don't have a 2. Only in the numerator we have a 2. So cos theta and cos theta will get cancelled. Sine and sine will get cancelled, leaving you with 2. So 2 is the answer for the second. So the answer is option C, which is 2. Let us try to understand third subdivision. So in third subdivision, they have given ck plus tan a into 1 minus sin a. So even this question, for this question, we'll try to approach this with in the same way that we did in second subdivision. So sec a can be written as 1 by cos a, and tan a can be written as sin a by cos a. We are trying to convert each term in terms of sin and cos. And the other term, I'm not going to change it because it's already in terms of sine. This term, I'm not changing it, whereas the first term, ck, I'm converting it to 1 by cos a, and tan a, I'm writing it as sin a by cos a. Now you get 1 plus sin a divided by cos a into 1 minus sin a. I have not changed the second term. The first term, the numerator becomes 1 plus sin a divided by cos a. Here, there is no need for LCM because the denominators are already the same. Now, the numerator looks like a plus b into a minus b. You have 1 plus sin a, 1 minus sin a. So this would become a square minus b square divided by cos a. Now, 1 square is 1, 1 minus sin square a. And we all know that 1 minus sin square a is cos square a from the identity. So this will become cos square a. 1 minus sin square a will become, this is not cos square a, this is cos a. Okay. So 1 minus sin square a will become cos square a, and the denominator is just cos a. Cos a and one of the cos a in cos square a get cancelled, leaving you with cos a. So cos square a is nothing but cos a into cos a. Let me do one more step for you to understand it better. So cos square a can be written as cos a into cos a. This is just for our understanding. And denominator we have cos a. One of these cos a's will get cancelled, and you're getting cos a, which is our part D. With respect to the fourth subdivision, it's quite direct because we know 1 plus tan square a is nothing but sec square a according to the identity. And also we know that 1 plus cot square a is cosec square a. So these things we know. Now sec square a can be written as 1 divided by cos square a. Likewise, cosec can be written as 1 divided by sin square a. Because we know that cos is the inverse of sec and sin is the inverse of cosec. Now in the next step, what happens is 1 by cos square a remains the same, whereas 1 by sin square a goes to the numerator and becomes sin square a by 1. This goes to the numerator. Now, this can be combined and written as sine square A divided by cos square A. 1 into sine square A, sine square A, cos square A into 1 is cos square A. So we know that sine by cos is tan. Therefore, sine square A by cos square A is tan square A. So the answer is option D.